Thank you. Thank you. Changing data is easy. I know it's a bold statement, but let me guide you through it. All we do, or most of the things we do as software engineers, is changing data. Think about it. Most of our apps are constantly creating, reading, and deleting data. So changing data is one of the most common things we do, and we've been doing it for very long. And even when we talk about transactional changes, where you need to change data in multiple tables, this is still a very common and straightforward process. So changing data is easy. Well, is it really that easy? Let me rephrase this. It used to be easy. However, we went from these big monoliths where everything was centralized, and we decided that it would be fun to decentralize these monoliths. And even worse, we decided, for some reason, that it would be even more fun to have them in separate networks. I think we have a problem now, and I'll explain why. What if our changes affect multiple services? And you need to guarantee that your data is kept consistent throughout these services. How do we make our transactions atomic when databases are spread throughout networks in different services holding different data? And how do we deal with concurrent reads and writes, where services are constantly talking to each other, constantly making changes, and we need to guarantee that our data is not corrupted? Furthermore, how do we deal with failures? Because we all know that services aren't perfect, things go wrong all the time. So how can we deal with these failures? That's what I'm going to talk about today, and I'm going to use an example that I've been actually working on very recently. So I work for Cover, which is an insurance company. And one of the biggest challenges we have at Cover is, what if a customer needs to change their data? If you think about insurance, data is critical. You need to have your data at the most correct state at all times. So if a customer says, I need to change my annual mileage on my car, or I need to change my residence, you need to guarantee that this data is changed accurately and is reflected across all services. And remember that a data change is always reflected in a policy. Your policy must have your most recent data, your most up-to-date risk, so that you know how much you're paying and that if you have any problem, you are correctly insured. So let's take this example. We have a customer that wants to change both his profile data and his vehicle data. You can think of profile data as his surname, his address, things like that. Vehicle data is essentially your car and how you use your car. So how many miles you put on your car per year, what's the estimated value of your car? And after these changes are made, we need to reflect them in our policy service. So this is the example I'm going to focus on today, is these free services. So to solve this problem, our solution is the Saga pattern. And the Saga pattern, this is not an acronym, it's just named Saga pattern, is a sequence of local transactions where each transaction updates data within a single service. This means that each single service is responsible for managing its own data. And this data change happens in a coordinated way. So how can you implement a Saga pattern? There are actually two approaches to this. The first one is choreography. And with choreography, each service is responsible for emitting events and consuming events to know when they have to change data. So for example, we start with some sort of request. Suppose that this request comes to an event queue or something like that. We have this event sent to the profile service. So the profile service is consuming this event and knows that it needs to change its data. It then goes to the vehicle service that knows that profile service changed the data, profile service emits an event, now vehicle service will listen to it and change it. And then it emits the events to a policy service, and finally we can finish off by saying that the changes are done. The other method we have to implement this is orchestration. And I find this personally to be the more lasting and robust, and I'll explain why in a bit. So with orchestration, you have one service that is coordinating all these changes, and that's that change orchestrator up there. So the change orchestrator is responsible for saying, okay, I have a new request coming that a customer needs to change their data. So I'm going to coordinate all these changes throughout my services. So that means that this service will send an update command to each of the services through a message broker, and each of the services will be prepared to listen for these commands. When each service finishes updating the data, they will then send a message to the reply channel, which our change orchestrator is set to listen to. And that means that the change orchestrator is the brain of the whole operation here, and each service doesn't need to know about any other service. So which patterns should you use? I guess this answer doesn't really surprise you because this is most of the answers we give as software engineers. It depends. Choreography tends to work best for simpler workflows. So when you don't have a lot of services involved, when there's very simple changes to do, it might be simpler to just go with choreography because you do not have to create a new service to do this. But orchestration is more suitable when many participants are involved. And moreover, it's more suitable when you think that there will be more participants involved over time. So I feel that orchestration is more suitable for the long run. But if your changes are quite simple, choreography might be the best for you. So how do we implement the orchestration Saga pattern? I'm going to guide you through some code examples here. So coming back to our diagram, let's first focus on this part, our change orchestrator. So first of all, when we set up our change orchestrator, we need to tell it to consume the messages coming into the reply channel. And they will be handled by a function that I call here handle reply. And then when a request comes to create a change to our data, we will need to grab the request data, the payload, create a message, and then we publish to the first channel we want the data change to happen. Now, which channel you use can be dependent on your business logic, or it can make no difference whatsoever, because all the changes eventually will have to be done. So in this case, I use the profile as the first service that I want to make a change, but I could have used vehicle. The one service I couldn't have used here would be policy, because policy depends on all the other changes being made. So it makes sense that that is the last service to be changed. So moving on to our profile service. So now our profile service received a message in this profile channel to change its data. So how does it work? Again, we set our profile service to consume the events that are coming into this channel, and we handle the update of this data. And that means that we have this update handler function, and when a request comes, we see what the command was that was given. And if it was an update command, we simply do our update. So this does a database update. And then if this fails, we will publish to the reply channel a command telling our orchestrator, I failed, do not proceed, this change cannot proceed. But if everything went well, we'll just publish on the reply channel, I'm updated, do whatever you need to do afterwards. So now coming back to our change orchestrator and how he listens to that reply channel. So orchestration tends to be well modeled by state machines. I'm not going to go into too much detail about that because I feel like that's a whole separate talk. So here what I'm doing is I'm just using a simple switch command to handle all the replies. So what we have here is the sequence of commands. So if we received an updated command from profile, we know that the next thing that we need to do is update our vehicle. And that's why we then we prepare a vehicle message, and then we publish an event so that the vehicle service will listen to and will change its data. If the vehicle updated correctly, we then update our policy. So we send a command to our policy channel for the policy service to then update its data. And when the policy is updated, if everything went well, then we can just leave, the changes are applied, all is good. Now, you need to be aware of one thing with this type of orchestration. So suppose that we want to change our occupation from being an engineer to being an MC, for example. Now I want to be an MC for GopherCon. So we have our profile service, and we start our change because we received an event saying, change the occupation of this person from engineer to MC. Okay, we change it. And now we have the policy service that for some reason needs to get the data of this customer at this point in time. Okay, so at this point in time, our occupation, since we already started the change and we already changed our profile service, our occupation here is MC. All good, except something happened in our system here and it failed. So now we will need to roll back the data in our profile because we want the data to either be reflected on all of our services or none at all. So we need this data to be rolled back. So when we roll back this data in our profile service, we now roll back to the engineer occupation. However, at this point in time, the policy service got an occupation of MC. Now this is wrong. This is not correct. Our customer's information hasn't been updated yet. So one of the ways you can solve this is by using a locking system where essentially any reads or writes while a change is happening, you will not allow anyone to read or write data from this. And you will defer the reading and writing to the end of your changes when everything is okay. So in this case, we prevented policy service from reading at this point, but when policy service read, it actually got the correct occupation. So all is good. This is just one way to handle it. You might consider that you can go for the optimistic scenario where you say, I can always guarantee that eventually the occupation will be MC, so I'm not even going to worry with locking this data because this is how I want my data to be, so let me just go with it. And that's also perfectly valid. So it all depends on your business logic and how you want to manage your business. But what about when things go wrong? And I don't mean this locking state. I mean that particular failure that I mentioned before. So that point in time, what happens then? How can we actually roll back our data if all of this is happening asynchronously? Well, you need to consider data versioning strategies so that you know how your data looked like in previous points in time. One of the options is to, for example, add a revision number to your data. This involves a new column in your table with a revision number where you can increment these revision numbers, you sort them, and you know which one is the previous revision number. You can use other database-specific strategies. For example, Mongo has a document versioning strategy where you create a separate collection just with all of your previous revisions, and you have just one with the official revision. You could, for example, in another scenario, just add a new column, and that column will contain all the state of the previous revision. I personally don't like this because it tends to just pollute your database with a big column, but it's always up to you. So imagine, and this would work better if Matt Ryer was actually here, but suppose that Matt Ryer wants to change his occupation from engineer to MC. In a traditional way, we would do an update to our database, and that occupation would then just be MC. With revisioning, what we have is a new column called revision. In that column, you should think that this column should be, you should use a UID, and you should make it sortable so that you always know how to sort your revisions. Okay, so if something bad happens, so for example, the vehicle service failed to update. So now we have this coming into our handle reply in the change orchestrator. And the change orchestrator now knows, okay, if this failed, I need to tell all my previous services that already did a successful update to roll back. And that's why we publish a new message into the profile saying, please roll back. And then profile will know that if I change this occupation to MC at this point, I will then need to grab the occupation that was there before in the previous revision and then do a new update with a new revision, but with the data as it was before. And that's how we can manage our rollbacks and keep data consistent. And then you might say, what if the rollback failed? And that's when you get into more serious problems, and that's when you start having more strategies of using observability to see when things go really wrong, having retries. I'm not going to dig much deeper into it, but it can get messy, and this is not the whole story. If you want to see these examples, you can go to my GitHub repo. It's still in a very beta phase. Didn't have much time to polish it, but it's working for now. So some tips around implementing sagas and making them work the best for you. First of all, use unique transaction IDs for all of your transactions. These transaction IDs will be your friends not only for traceability purposes Or if you need to use them to fetch some additional piece of data, you can always use this transaction ID to know what you're referring to. And they're also very useful for when things fail, or when your message gets delivered twice, you don't want to update your data twice. You don't want to add multiple revisions. So transaction IDs actually help you know if this new request to change your data is actually a new request that came from a customer, or is it just the same transaction that for some reason our message got duplicated and we got it the same message again. Idempotency is also very important. Make sure that your services can be tried and retried, and you get the same result over and over again. This will guarantee that if anything fails in your system, when the systems go back up, you can always retry that request, and you can guarantee that you're getting into a good state of the data. Always provide the data to the services instead of relying on each individual service to make additional requests to get this data. So in this example, if I tell profile service update, and then profile service has to make a request to the orchestrator to say, okay, get me the data to update, this defeats the whole purpose of the sagas, because then profile service is not acting in isolation. One of the good benefits if you provide the data to the services is that they can grab this data and they can self-update, and if everything goes wrong, if all the network goes wrong, this service could still grab this data and update itself. So never rely on having to have service-to-service communication unless it's an additional piece of data that is not included in a request. But still, I would recommend that you always provide all the data that is needed when making the requests. Observe your sagas. Observability is very, very important when you have all of these services acting asynchronously, where things might fail, where you might need to debug, where you might need to see, did this data go into the correct state? So use your metrics, use your logs, use your traceability, use everything that you have at your disposal to observe how these interactions are going and if your system is in a healthy state. So I guess that changing data isn't that easy after all. And I personally had the experience of systems that weren't using a Saga pattern, but still had to change data in this way. And where we got to states where something terribly failed and we had to manually change data. And I think that it really isn't good for any engineer to have to manually change data in databases or have to manually roll back things, especially if you think about the scale of customers you might have. You don't want your engineers to be going to database, making manual commands to revert data or to put the data back in the correct state. So it's really important that you think of your systems as a self-sustainable system, a system that can self-heal, that can recover from any failure that might happen. A system where you know that you can leave that for months and months and months, and you will rarely need to go into that system and check what's going wrong, because that system will have the capability of healing itself. And patterns like the Saga pattern is what help you achieve this. It's these types of patterns that will guide you through how you can make your systems be self-healing, be consistent, be coherent, and always have the right state of data. And that's all. Thank you. Any questions? I don't know who has the microphone. Is the microphone around?
Where is it, sorry?
Hey, thank you for the talk. Don't you have to lock all the services in order to guarantee atomacy on your update or rollback? Because if you've got multiple updates, you would otherwise struggle knowing where to roll back and stuff.
That is where, thank you for the question, first of all. That is where distributed locks are your friends. So you would have to have, and Brian actually mentioned this before, with things like etcd, you would have to have a separate system that will tell you that no reads are allowed to occur on this entity as a whole. So you would need to lock any reads or writes from this given vehicle ID and this given user ID, and that would guarantee that no data could be read from any of these services. But yes, you're absolutely right. No service can allow any reads or writes once they are updating this data.
And so then one follow-up question: did you ever did you ever experience there for performance issues? Because in a distributed system, those locks, obviously, might be fairly long, maybe.
Sorry, I didn't quite get the question.
So I mean, because even a distributed system, if you have to lock across different services.
Mm-hmm.
I guess those locks are, hold on for quite a long time comparatively to maybe more traditional databases, but where you just, so did you experience performance issues because of that Saga pattern?
Not really. I'm going to be honest, this isn't, we actually haven't gotten here yet. This is something we're working on. But what I can say is that you can expect that these locks, they shouldn't take too long. So you shouldn't be, your data, systems nowadays are made so that your data doesn't really need to hold on for too long until that lock is released. So if you have a good system for that, I think you'll be okay. And I've heard a lot of examples that have to use this locking, and banking is one example where if you think about having the state of your account, where if something fails and you try to pay something twice, you need to really lock that data. And everything needs to happen very fast, so I think systems nowadays are ready for these locks to not take a long time. So you shouldn't worry too much about that, but it's still a very valid concern. I don't have personal experience with it, but I know that it shouldn't be a big concern.
Cool, yeah, thank you.
No problem, thank you. So I think that this gentleman here had the first.
Yes, thank you for your talk. The question is about commits. You mentioned rollbacks, but if a service is supposed to hold the lock on the data that's changing, and if it's already changed it, it must know probably that the whole transaction is complete. So do you send commit commands?
So the commands that you should send is after you roll back, you would send the command to the orchestrator saying, I'm rolled back, so that the orchestrator will know that all the services involved rolled back and he can release the lock. So in fact, that might be the commit command that you're referencing to.
I mean in the other direction. If you told the profile service to change the profile, how does it know for how long to hold the lock? How does it know that the other parts of the transaction are finished, or does it need to know?
So it doesn't really need to know. All it needs to know is I have to update my data, and I have to report back that my data is updated. And that's all it needs to know, and it has absolutely no service in an orchestration. No service has really any clue that any other service after it or before it is making updates. And it's up to the orchestrator to actually know how these services are coordinating. And it's up to the orchestrator to deal with how long it will wait for a service to update until it considers that, okay, this is failing. So yeah. I think there's someone over there.
Hi, yeah, thank you for the talk. So you're placing quite a lot of stress on the orchestrator then, and also obviously if it fails, it needs to know how and what to orchestrate after that, and how to continue when it comes back, like pick up the logs and so on and so forth. So I guess your orchestrator is then the bottleneck of this whole operation.
That is one of the drawbacks of orchestration, is that you add that single point of failure. And hopefully nowadays, with all the replicas that you can have, you can guarantee like how many times you actually have a full system just going down. Probably not that many, because if you can rely on replicas, if you can rely on having your system replicated so that you always have the guarantee of an uptime somewhere, you shouldn't fall into that scenario often. But I think that's a subject for a whole different talk of just how to deal with all the crazy things that can happen in this process. And I think it's a bit out of scope, but you're right, it's tricky to then make it go up. But if you rely on your queues, if you rely on keeping some sort of state, because that's one of the things I didn't mention, but if you keep some sort of state with your orchestrator of, I have this change in progress, and this is happening, and then it went down, it goes up, and it sees which of the changes it still has in progress, you can sort of handle these failures. But yeah, I think that's a whole different talk. You gave me some ideas. So 2 people here.
Hello, thanks for the talk. I was just wondering about the self-healing thing at the end. How would you might go about testing something like that? The failure cases and the chaos maybe. So
What type of tests? Integration testing?
yeah. So, like, how is it actually working? Yeah.
You can always simulate potentially via either some specific message that will make your system fail, like a specific payload in your command that you know that your system will fail. That is one alternative. I think you can think of different strategies. I think it's hard to test these systems. It's not that trivial because there's a lot of components involved. But you can get creative and just try to find a way to make your system fail. Like send some type of corrupted data to your system, for example. Something that your system, you know that it won't deal well with it and it will fail. For example, an invalid ID, an invalid name, an invalid value. Any type of thing that will make your systems fail you will be then able to test failures in your system.
Hi. Did you consider using write-ahead logs or two-phase commits as part of this?
So we have a sort of two-phase commit in place at the time because we aren't yet using sagas for this. This is kind of a next step in our system. So what we're doing is we're actually making synchronous calls. Two-phase commits are not a recommendation just because of how things can fail. So currently we're making synchronous requests, but if a request fails, we'll need to fix it somehow. There's no way of self-healing because you don't have a queue, you don't have things that can make your system be self-managed, and it can be a bit clunky. So it's never too recommended in distributed systems to use two-phase commits. So I think we have one here, one over there.
Hello, thanks for the talk. I had a question about some of the details in your example. I was wondering, in your example, does the policy service reference the revision ID of the individual data? And whether the example where you had a rollback where it's a new row, whether you could do it just by referencing the older one.
So the policy service can definitely use the revision of your data, but in terms of rollback, how would the policy service know what is the previous revision of the profile data? You can definitely make it. You can one of the options is with your revisions also have a field that tells you which one is official and which one is in staging, and you can, I guess, just make a query from your policy service to your profile service and say, get me the latest committed stage instead of the latest staged one. But I think that if you use rollbacks in this way, where you always get the latest version of data, and it's up to the profile to always know what the latest version of data is, you get less dependencies and less business logic to deal with in these cases. One question over there.
So you mentioned that that you cannot update the policy service before all the changes to the rest of the services have been applied. So are you enforcing that order somehow with the state machine? Do you have a distributed state machine?
No, we don't have a distributed state machine. And again, I don't have experience with state machines personally, full disclosure. What we do is just guarantee that the last step in your events is just that last service. That's the most simplistic way that you can think of it. If you tell the orchestrator has to know in some way what is the next step, what is the subsequent step. So profile updated, what is the next one? And the policy service should be the last one on that list. And that's kind of the naive way to guarantee that the change orchestrator will always call the policy service last.
So you have a hard-coded list of service updates.
Yeah, essentially that. You can think of it that way.
Cheers.
I think there's one question over there.
So do you think this pattern can be enhanced by using a message queue?
Well, the message broker that I mentioned is already a message queue in itself. How do you mean enhanced even further?
For example, you were publishing to specific consumers, right? You had the 3 examples there. So you could do something like publish the entire message with all the data that needs to be changed and have the consumers decide what they need to consume.
How would you know that it's a possibility, but think of the complexity that it adds to your system, because if you update all the services at once and one of them fails, you will then need to know to update the other one. It gets a bit trickier for rollbacking failures and everything, but it's definitely a possibility. Something I didn't mention, but profile and vehicle, they could actually be updated at once. But if you want to keep things simple and if you want to keep things self-contained, it's better to do it step by step. But that's, again, a decision that will rely on you. I really don't know which one would work best. I just feel that it might be safer to just do them step by step. But yeah, if you have 10 different services that you need to change and they can all change at once, it can get too lengthy. So you can use just one single push and every service will update itself. But it can get hard to then know how to roll back correctly.
Thank you.
There's one question over there.
Sorry, where am I going?
Hi. What if you're using a database that supports transactions? Do you just use this model entirely and abandon that feature, or like have you been able to like use both of them? It's pretty specific to the kind of databases like Postgres. So I was just curious about that.
So you can use transactions when you have a central database, but if you have your systems distributed, it gets harder to choose transactions. So you need a way to do the distributed transactions, and that is the problem, is that our database is no longer centralized, it's spread out. So you couldn't really use transactions in this case. I think there's a question right there.
Thank you for the talk. I'm
sorry, I can't hear you very well.
I'm trying to better understand how this works from like an event-driven system. So if you think of a more classical event-driven system, you have an order, you have an index. So when you get to a point of failure, you cannot continue, you cannot progress through that. So how can you deal with an orchestrator and at the same time have like partitioning? So if you have a profile and transactions, I don't want to stop being able to process transactions if my profile fails or vice versa.
So what you're asking is if you're able to still do all of the changes even if one of the services fails?
Yeah, so would that decision be up to the orchestrator, or would you break up the state machine somewhat?
So a part of what you told me seems like a good use case for choreography, because choreography does deal with events. And in the end, the decision of rolling back or moving forward, because it's perfectly valid that you consider, okay, profile failed, But at this point, imagine you didn't have a policy service to care about. And imagine your data really isn't that critical, and you can assume that your data might have failures and you'll update it eventually. You could definitely go with that. You could definitely say, update all my services. I don't care if they fail. Just put the changes there. If any service fails, I'll just retry it later, and the data will eventually be correct. And that's a perfectly valid approach. You don't always need to roll back, and that's not always the solution. So in your case, you just need to, if you have an orchestrator, your orchestrator, instead of having a rollback handler, it only updates the data and doesn't care anymore and just waits till everyone replies. And if one of the services says, I couldn't update, then the orchestrator can just be responsible for retrying that. And with events, if you use choreography, it would kind of be the same concept. If profile failed, profile can still emit an event, I'm finished, whether I failed or not, and then have some sort of way of managing the retries.
Thank you.
Okay, I think we're done with the questions. I don't see any other hands up. Oh.
Hi. My question was in relation to large amounts of data. So say you're trying to use the revisions, and then doubling your data is an insane amount of data to be having. How are you dealing with deleting revisions and trying not to, overload your database with unnecessary information?
That's a very, very good point. And I completely agree with you. You shouldn't be storing revisions that happened a year ago. And once again, this is something that will depend on your business logic and decisions. You can decide, for example, that you keep revisions for a day, you keep revisions for a month, or you can decide that I'm only going to keep the last 5 or 6 revisions, or the last 5 or 6 revisions as long as they happen throughout a month. So you can use some strategies to avoid, as you said, having insane amounts of data in your database. And if you use the Mongo strategy of having just a separate document, or in SQL a separate table, just for your revisions, you can have that table just be truncated every now and then. So it all depends on your business logic, but that's how you would go. But you are right, and revisioning can add a lot of duplicated information to your table. And if that's not acceptable, you can always think of any other alternative to version your data.
There's one more here. I don't know if you can see them. Hi. How do you achieve idempotency with revision numbers?
Sorry?
How do you achieve idempotency with revision numbers?
I didn't get the first word, I'm sorry.
Idempotent.
No, how do you?
Achieve.
Oh, with version numbers. So you can always use, I think idempotency wouldn't be as related with the revision numbers as it would be with your transaction ID. So, for example, if you say update this data, and this is the transaction ID, and you already have an update going, or an update already went through that had that same transaction ID, you're not going to repeat it, so you're not going to change your revisions anymore. So your final revision will be dependent on the transaction ID that you provide. So if you provide a new transaction ID, then yes, you're creating a new revision. But if you then retry it with the same transaction ID, then that revision will not change, because you will not make that change because you know you already processed this particular transaction ID. And that's the way you can achieve idempotency with that. Okay, I don't see anyone else raising their hand. So I think, oh.
I was just wondering whether you think it's worth all the hassle compared to a compared to a standard Postgres system or something with transactions.
Compared to?
Something like a traditional Postgres with transactions and so on.
But how would you manage the distributed transaction things?
Well, that's sort of the question. Why would you have it distributed?
Because
could you potentially like shard your Postgres by customer rather than by service, for example?
Well, but then you kind of violate one of the principles, which is you're using shared databases between different microservices, and that might not be the best approach. It's a possibility, but in this case, I'm talking about when you have the distributed systems with their own database, this is how you would solve it. The question of if you want to go for the trouble of having distributed systems with distributed database, I think we can discuss that for a whole day among us, and we won't have a right answer. So it always depends on your use case and if you actually want to go for this trouble. One question here.
You're loving running around like this. Hello, great talk. Unless maybe I missed it at the beginning, what technology stack are you using? Are there any kind of primitives within your messaging system that allow you to sort of enable some of these sagas?
We are still in process of implementing, but what type of, so I'd say for message broker, a RabbitMQ would do fine. EventBridge, anything that deals with messages, Kafka. Database, this applies to any type of database system. Yeah, what else?
So you kind of had to build a choreography on top of...
You have to build a choreography. I don't know. I think I've seen some libraries that do some sort of generic sagas. I think there are libraries out there for this. But I think if your business logic is very specific, you'll end up to have to implement this choreography or this orchestrator yourself.
Yeah, so like things like outbox patterns, you know, with some of them you get those free, but then I suppose you have to build those on top of...
Yeah. So we built it from scratch.
Yeah, okay.
Because it's so specific to business logic that you tend to maybe have a harder time trying to reuse something rather than building your own.
Yeah, okay, thank you.
No problem. There's one question over there.
Sorry, one more last question. How do you guarantee also that nothing else in your distributed system, which might be massive, is going to send the message to your profile service to update and circumventing your orchestrator? Do you use how do you protect that from happening?
Very, very good question. One of the solutions you can have is you can use a specific code that only your orchestrator will use. So if you think about the example of a service calling another service, like a normal HTTP request where you put in the header your user agent, you can have some sort of user agent to say this came from the orchestrator. Because you're right, there is no way to prevent that another service will publish a message to that channel and just blow it all out of proportion. So it's a decision you'll have to make and think about, but one of the solutions could be to add a special header, if you may, to your message payload so that the profile knows that it came from the orchestrator.
Okay, yep.
Another question over there.
Hi, thanks for the talk. My question actually has to phases. I noticed that you are not overly concerned about giving quick feedback to the customer that is updating that data. And also, how do you suggest to deal with cases where rollback is not possible? Situations where you send an email to a customer or a notification on an application. How do you suggest we deal with that?
So, as to your first question, I'd like to stress that it looks like a very complicated process, but these things happen fast. And if given that your systems should all be kind of in the same network and kind of sharing the same location, these requests should go pretty fast. Like, this is not an operation that will take more than 5 minutes. I think even 5 minutes is a bit of a stretch. So you can expect these changes to happen really fast, even though it seems like a very complex process. So if you're okay with the customer I would say that the customer will probably know that the data has changed in 1 minute, less than 1 minute, I think. I don't really know, but it is. I can guarantee you that this is fast. As your second question, which was, sorry, can you repeat the second question?
How do you propose that we deal with situations where rollback is not possible, where you already notified the customer about having something?
So that is why you should always leave the notifications as the last step and as the cleanup, and potentially even not even using a Saga to send out the notifications. And that is why I mentioned that the policy service is always the last one to be updated, because you only want to update the policy service once you can absolutely guarantee that all the data changes happen. And with the notifications, it's the same thing. You only really send out those notifications or confirm all those changes at the end of this saga.
Okay, thank you.
I think there's a question back there.
Thanks for your talk. My question is about how you handle message ordering and parallelization at the same time. Like, for example, if you get a message of profile update followed by a vehicle update, but you also process them in parallel.
So that's where you start to get a bit creative. That's where these systems can grow in complexity, because if I understand you correctly, you might want to be able to get the profile message and to do 3 things at a time and then do something else. And that's where you kind of tell your system how to deal with that. It's no problem to, when you receive that profile updated command, you don't need to necessarily just say vehicle update this. You can say, let's do some data crunching here, or let's do some separate process there, wait for that process, or do this separate process and update vehicle. So you can get as creative as you want with this. There's no hard rule that you should just update this and update that. There can be a lot of steps in between these updates. I just didn't want to also overload this presentation with things that would clutter it. But it really is up to you how you implement this. And the possibilities are endless. You can even, for example, you can combine an orchestration with a choreography where you say, this is a big process where 3 services are involved, and these 3 services depend on each other to update their data. And you can orchestrate getting the profile service, and then in the vehicle you have other 3 things to happen, and you can do a choreography with it or another orchestration. So yeah, sky is kind of the limit here. Okay, I think I'm going to close the questions for now. I think we had a really good question. Thank you all for coming and for asking all these questions. It was really nice chatting with you today. Thank you.
Hey. Excellent stuff. Brilliant. Thank you so much, Tiago. I've never seen that many questions for a talk.
I felt like I was at a job interview.
Yeah. How did he do? He's not got it, has he? No. Yeah, I thought that so many questions. Either the talk was very inspiring, or
it lacked a lot
of content. Yeah, so feedback for next time. But thank you so much. It was actually genuinely very interesting. Good stuff.
Thanks, Matt.
Thanks, Tiago.
Thank you.
Tiago, everybody.